This lesson, 6.4, we're designing and conducting a simulation for a simple event and a compound event. In our previous module 5, I don't know if you remember when we did that simulation in class where we flipped a coin and rolled a die. Well, when we were conducting that simulation in class, we were doing it without technology. We were using the coin and the die to conduct our simulation, but one of your TEKs says that students are expected to select and use simulations with and without technology. So this lesson, we've already done it without. This lesson is involving using technology. I wanted to let you know that you are going to need a random number generator for this lesson, and you could use a computer. You could search for a free random generator on the internet, or you could use a graphing calculator to generate your random numbers, or you could use your smart device. There are apps that have free random number generators. So before we get started, you'll need one of those. Okay, remember that a simulation, we use it when something is too difficult or too complex to perform. So we are using a simulation to use something according to the circumstances of the problem. We're modeling something that we could perform. So we're going to read this first example. A cereal company is having a contest. There are codes for winning prizes in 30% of its cereal boxes. Find the experimental probability of having to buy exactly 3 boxes of cereal before you find a winning code. When you're choosing a model, since it has to go with the circumstance of the problem, and it's talking about the winning codes being 30%, well, you know that 30% would be 30 out of 100. Okay, so when we simplify that, that is 3 out of 10. So that means that there are going to be 3 winning codes out of 10. So when we are modeling our simulation, we are going to let 3 numbers represent a winning code. So we're going to say that the winning numbers are going to be whenever we generate a 1, a 2, or a 3. Those are going to be our winning codes. And when you generate any of the other numbers, 4, 5, 6, 7, 8, 9, or 10, those are obviously the non-winning codes. So what you do is you generate these trials and you perform multiple trials, okay, and you're recording how many boxes of cereal you had to buy until you get one of these winning codes, okay, and then we're going to find the experimental probability. Well, to save on time, I went ahead and just have the information here for you. This is how you're going to see the information presented on a test. Okay, so the data will be here for you, but you will have to know how to read it. So let's talk about this. In the first trial, we generated 5 random numbers because it took us 5 numbers until we finally saw one of our winning codes. Remember, a 1 is a winning code. So we had to buy 5 boxes of cereal in the first trial. In the second trial, when I generated a number, a winning code came up right away. So I only had to buy 1 box of cereal and I have a winning code. In the third trial, excuse me, I had to buy 4 boxes of cereal before coming up with a winning code. So on and so forth. We're trying to find the probability of buying exactly 3 boxes of cereal. So we're going to write the probability buying, I'm just going to say buying 3 boxes. Okay, so the probability that we had to buy exactly 3 boxes, you see right here, we had to buy 3, and we got our winning code. How many times did that happen in our 10 trials? Well, it only happened once. So it happened 1 out of 10 trials, so our probability is 1 out of 10, or 10%. Okay, so that is what we're looking at in this lesson. And again, this was only a simple event. So now in the your turn, you're going to need a random number generator. And you are going to, let me read this for you so you'll understand what you're doing. Okay, an elephant has a 50% chance of giving birth to either a male or to a female calf. Use a simulation to find the experimental probability that the elephant gives birth to 3 male calves before having a female calf. Because it's 50%, okay, and remember when you choose your model, it has to be specifically for this circumstance, and 50% you know is, well, 50 out of 100. Okay, when we simplify, when you have a 0 on top and a 0 on bottom, you can cross them out. So 5 out of 10 is the same as 1/2, 1 out of 2. So since it's 1 out of 2, they tell you to use zeros and ones. Okay, those are the only numbers you're trying to generate, zeros and ones randomly. Okay, so the 0 is going to represent a male calf, and every time you get a 1, that's going to represent a female calf. And you're going to tell the numbers that are generated here, like how many males did you have to have before having a female, or did you get a female right away? And then over here, how many males, you're going to write how many males you had to have before having a female. But you're going to have to do this with a random number generator. So I'm going to have you pause your video and try to do this simulation with a smart device or a computer or a graphing calculator. Pause your video. All right. This app is one of the free apps I was talking about, and it should let you go. There's a few different apps, but should let you go into the settings and tell from what number to what number you need to generate. When it says number of results, well, I just want to make sure I have enough, so I just put give me 50 random numbers between 0 and 1, and when I hit generate, it generates 50 random numbers from 0 to 1. So now I can use these results to perform my simulation. So you notice that I have 0, 0, 1. Remember, the zeros are males. So in my first trial, I have a 0, and a 1 until I get my female. So I had to have 2 males before I got a female. Okay, so that would be one trial. Then you notice that I got a female right away, so I had to have no males. Then I had another female right away, so I didn't have to have any males. Then I have a 0, 0, those are males. I had another male, oh, then a female. So I had a 0, 0, 1, so I had to have 2 males before having a female. And then I had, in the next trial, a male, and then I have a female. I only had to have 1 male there. Move this over. Okay, in the next one, let's see, so I had that male. Okay, so I have a male, and then I had a female. I only had to have 1 male on that one. 0, 0, 1. Okay, so 0, 0, 1. I had to have 2 males, and then I have actually, I have 3 females in a row, so I had to have no males, no males, no males. So, okay, sometimes this is going to happen because I've actually done this before, and there was only one time that I had to have 3 males out of, before getting a female. It happened once. Well, now when I generated these random numbers, it didn't happen at all. So, for this particular simulation, the probability of having 3 males before you have a female was actually 0. Okay, and the last time I had done this experiment, it was only 1 out of 10, which was 10%. So that tells us that having to have 3 males before having a female is very rare. Okay, so that's why they use simulations, just to get an estimate, and sometimes this happens, and your information is going to be different from mine. So in class we could discuss what you all found. Okay, so on the back, we're doing the exact same thing, except that you're doing a compound event. So in example 2, suppose that there is a 20% chance that a particular volcano will erupt in any given decade. Find the experimental probability the volcano erupts at least one out of the next 5 decades. That's what makes it compound, because at least one is going to mean more than one number. So because we have to create a model that goes with our problem, it's talking about this happening 20% of the time. Well, 20 over 100, simplify, 2 out of 10 would be simplified to 1 out of 5. Okay, so we're going to generate 5 random numbers, okay, from 1 to 5, and we're going to record the number of decades with an eruption. So we're going to have to say, okay, well, we're going to use whole numbers from 1 through 5. I'm going to let a 1 represent an eruption. So every time you generate those 5 numbers, you're looking for, where did I get a 1? Okay, so again, the information's here for you, and that's how it will be presented on your test. And you'll have to look at the table and say, okay, well, here I got a 1, and it happened once out of these 5 decades. In these 5 decades, it didn't happen at all. These 5, it happened once. Didn't happen at all, didn't happen at all, didn't happen at all. It happened twice in these 5 decades, and then these 5 decades it happened twice, and then these 5 decades it happened once. Well, when you go find the experimental probability that it happens at least once, well, then that's going to include the 1s and the 2s. So how many times did this happen in the next 5 decades? It happened 1, 2, 3, 4, 5 out of how many trials? 10. So the probability of at least one eruption equals 5 out of 10, which you know is the same as 1/2. So you know that that's a 50% chance that there will be an eruption for this volcano in the next 5 decades. Okay, so on the your turn, it says Matt guesses the answers on a quiz with 5 true-false questions. The probability of guessing a correct answer on each question is 50%. Use a simulation to find an experimental probability that he gets at least 2 questions right. Again, you're using the numbers 0 to 1, so your settings on your number generator are the same, okay? You're performing 10 trials, and you're generating 5 random numbers in each, and you're trying to count the number of 1s because the 1s represent the correct answers. So pause your video and randomly generate 5 numbers in each of your trials and fill out your table. Okay, in my number generator, since it told us to generate 5 random numbers for each trial, I changed my 50 to a 5. So when I go generate 5 numbers, oh, actually, I should have cleared this. Give me a second. Okay. Okay, sorry, I had to clear those other results. Now I'm going to ask it to generate 5 numbers at a time. So it does 1, 2, 3, 4, and then the 5th one is up there. Okay, so I'm going to start with the one that's up there. I got a 1, a 0, a 0, a 1, and a 1. So that's what I'm going to write down. I got a 1, a 0, a 0, a 1, and a 1. So how many correct answers did I get in these guesses? I actually got 3 correct answers. Okay, now I'm going to generate the next 5 numbers. Oh, 1, 1, 1, 1, 1. Oh my goodness. Well, 1, 1, 1, 1, 1, 1, 2, 3, 4, 5. So from him guessing, he got all 5 questions right on his true-false quiz. That's really lucky. Don't get any ideas. You shouldn't be guessing. Okay, so 1, 2, 3, 4, 5. I got a 1, a 0, a 1, 0, 0. So I got a 1, a 0, a 1, a 0, 0. So here on my random guesses, I only got 2 right out of my true-false questions. Okay, generate another 5. And let's see, I have a 1, 1, 0, 1, 1. 1, 1, 0, 1, 1. So he got 4 correct answers on that one. Generate another 5 numbers. 1, 0, 1, 1, 0, 1, 1. That last one is a 1. Okay, 1, 2, 3, 4 correct answers. Generate another 5. 1, 1, 1, 0, 0. 1, 1, 1, 0, 0. That's 3 correct answers. Generate another 5. Oh my goodness. 0, 1, 1, 1, 1. I just think Matt is a really good guesser. Okay, so 0, 0, 0, 1, 0. 0, 0, 0, 1, 0. Okay, he only got 1 right that time. Let's see. 1, 0, 1, 1, 0. 1, 0, 1, 1, 0. Here, he got 3 correct answers right from guessing. 0, 0, 1, 1, 0. 0, 0, 1, 1, 0. Okay, well, of course, when you're guessing out of only true, false, and your chances are 50%, you have more chances of getting some correct answers from guessing, right, than if it was a multiple choice question with A, B, C, or D. So since zeros represented incorrect and ones represented correct, and the question was find the probability of at least 2 correct, at least 2 questions correct, okay? Well, that's going to mean that it's going to include 2, but everything above 2 is going to count as well. So we're going to count how many times that happened for us. So 1, 2, 3, 4, 5, 6, 7, 8, 9 times out of 10, we got at least 2 questions right when we guessed. So, or he did, when Matt guessed. So that's 90% of the time, that probability that guessing on a true-false quiz out of 5 questions that he got those, it's 90% that he'll have more than 2 correct answers. Okay, so we're going to work on these in class and generate some random numbers together. And again, your test will be presented where the information's already done for you and the questions will be asked about the data given. See you next time.